All right. Hey everyone, I'm Rohan Kamesha, one of the co-founders of DataZep, the original creators and maintainers of the open source tool called Olake. We are the fastest tool available to get your databases data into data lakehouses. And I'm super excited to be here at PrestaCon. Today, I'll be walking you through a hands-on playground that we have built to make it easy to experience an Iceberg native lakehouse. We'll be using MySQL as a source, Presto as a query engine, of course, and our own open source tool called Olake to basically bridge the data between the source and the query engine. So why do all of this at all? Let's be honest, setting up a data lake houses with Iceberg isn't really easy. There are multiple moving pieces. You need to get the catalog right. You need to set up the object store. You need to manage the schema. Within the ingestion itself, there are multiple moving pieces like Debezium, Kafka, Spark, your own Python scripts. So if you're just getting started, it can take days, weeks, or even sometimes months to get to that first select start. So our goal was to change that. We wanted to make it so easy that all you need is a Docker Compose up and you have a ready playground set up to experience what icebergs are all about, experience what lakehouses are all about, and even understand how Presto and Iceberg might work together. So let's take a quick step back. Let's understand what's Iceberg and why all of this is such a big deal. So Iceberg is an open table format built for data lake. It solves the long-standing pain points of high-style tables, of schema evolution. It has its own hidden partitioning, asset transactions, or asset native updates, deletes, merge. So it's basically like a metadata layer on top of the data sitting in Parquet formats in your data lake, which solves for things like partitioning and all. So within this playground, we'll be first setting up a source database called in MySQL. We'll load some data, sample data, and it will be using weather database to do that. We'll use Olake to discover the schema, get this ingested into the Iceberg format. We'll be using REST catalog to do all of this, the implementation given out by the Tabular team itself. We'll be simulating the S3 endpoints using MinIO. You can use your own S3 buckets if you want, and we'll be querying all of this using Presto. Uh, so basically an end-to-end from right from the source to the Presto all within the single playground within a couple of minutes. And it's basically this playground is meant for developers, data engineers, or anyone who's trying to learn how ClickHouses might look like, how Apache Iceberg and Presto might work out. Anybody who's trying to, let's say, the lower the cost of their data lakes or data lake operations, or have those asset kind of properties, or get to the more modern infrastructures of having multiple query engines running on the same data format. All of this is possible with Apache Iceberg. As I said, there will be multiple tools that we are using, but all of these are more plug and play. For example, within this setup, we'll be using MySQL as a source database that we'll set up within this old Docker. But of course, you can use your own staging tables, production tables, your own databases to test this out as well. Uh, we are using MinIO to simulate the S3 buckets, but you can use your own S3 endpoints to do all of this as well. The catalog itself, you can try out multiple catalogs. We are using the REST catalog by the Tabular team and query engine. We are using Presto, of course, to show the integration, but if you want to test out DuckDB, Trino, or any other query engine, happy to check it out. So diving right into it, as I said, this is basically a playground right from the source to the destination. We'll have a single Docker Compose. You can access that, all of those things within the Olake repo itself. You'll have an example folders within that Olake repo. And from that, within that example folders, we have a pretty amazing README file. You'll have like step-by-step ways on how to configure your own system to start running this playground. There's not a lot of prerequisites. It's simple Docker, and basically you need to clone the repo. Of course, like we can copy paste the files and then start running, but who does that? So you can clone the repo over here, do some configurations, like for example, change the persistent path and all, basically add your own system details over here. And from there, it's all ready to use. You can even change username password within this. Running directly into the demo side of the things, as you can see, I'm directly in the example tables, example folder itself. You can see the directory structure of this. It has its own Docker Compose, Presto folder with all the required configurations. It has Iceberg already set up for you, Presto required configs as well, JVM configs as well. And within the Docker Compose, we'll be spinning up multiple services. The first service that we'll be spinning up is basically an Iceberg REST with all its required configurations like AWS keys and all. We are using MinIO to simulate the S3 bucket. So you can see MinIO over here with default AWS region. You can use your own endpoints to do this as well. We'll be spinning up the warehouse within this. So S3 underscore S3 warehouse over here, endpoints, and so on. We'll be spinning up most of the services, or actually all the services within the same network, just to make it easy for internal orchestrations. And we'll be spinning up the MinIO, as you can see over here, as one of the services with the same network. And then we'll have like a primary MySQL. This MySQL will act like a source database for this playground. You can use your own staging tables or let's say staging databases or your production databases. Olake today already supports MySQL, Postgres, MongoDB to start with. So you can use any of these databases to do that. For the sake of this example, we'll be using MySQL. And in the next service, we'll basically load some sample data. We'll be using weather database to do that. We'll set up the CDC from there within the service itself so that we don't need to do all of those things manually. You can even Docker exec within this MySQL, your own table, add your own database to basically understand or maybe play around. All of those things are written in the README, like how you can do that. But for the sake of this presentation, we'll keep it simple. We'll just do a couple of things, and then the next service we'll be starting up is basically the Olake app. It has its own temporal based orchestration. For example, if you want a job to run between, let's say, your source, MySQL, MongoDB, Postgres, to Iceberg tables every couple of minutes, every couple of hours, this temporal would take care of that orchestration. And it has its own other configs as well, like sign up, initiate, and all of those things. So diving right into it, we can do a simple Docker Compose up. It can take a couple of minutes, and for the first time users of this, please wait for some more time because it may take some minutes to basically download all the images and all of those things. As you can see, we have I have most of the images already downloaded, so it took me a couple of less seconds, a couple of less minutes. Right now, it's basically setting up the CDC, loading the weather database into the MySQL, basically doing that initiate MySQL tasks. One of those tasks is basically loading a couple of sample data files. That's why it takes a couple more minutes, couple more seconds to do all of this. So while we are here, we can check out the README files. You can do, you can access the services directly from here. As I was talking about, you can directly Docker exec into this MySQL and query the data, create tables, anything you want, you can do directly from here as well. Just checking if all the services are started and are ready. We can even check it out within our Docker UI as well. If you are, let's say, a Docker UI user, you can check out that we have a MinIO running. We have a primary MySQL, which will act like a source for us. Then we have temporal UI. We have catalog, which is already set up. Olake, which will act like an ingestion between this MySQL source and Iceberg, basically an ingestion tool is already set up. So we have most of our services already set up. We can directly go check it out. I've not changed the admin password. If you want, you can change that. So for now, it's just admin and password for me. So taking a couple of seconds to go over the OLake UI itself. So OLake has three big components: jobs, sources, and destinations. One job is basically like one connection between your source and the destination. You can have, let's say, multiple sources, multiple destinations. Right now, OLake supports MySQL, Postgres, MongoDB as sources. We can do CDC. We can do full refresh for you. Incremental is soon coming up as well. And then we have Iceberg as a destination as well. We support most of the catalogs. We can even just push directly into S3 buckets as Spark files as well. So that is the another destination that we support. So jumping right in, to create our first job, we can choose MySQL as the source because we just started up MySQL service within that same Docker. If you remember, we can name it anything. For the sake of this example, I'm just naming it MySQL temp. All of these configurations, you can pick it up right from the README file. As you can see, I'm just going to do that as well. Yeah. So port is 3306. Database is weather. As we basically loaded some sample database called weather within this. You can check it out, or you can use your any other database, or if you're using your own staging databases to test this out, feel free to change these configurations. You can find out like how to add these or the documentation around it right beside this, so it's pretty easy to do all of these things. Yeah. And the next step is basically it will test the connection with the database, see if it is able to access, or see if the configurations are in the right format. It takes a couple of seconds to do all of this. And once it's done, we move to the next step, which is basically adding the destination configurations. And where there will be adding like how to add Apache Iceberg will basically add hosts and all of those things over there. The connection is successful. We are to the next step. As I was talking about this S3 as a destination as well for all the folks who are using, let's say, their own Spark jobs, Kafka, or Debezium kind of a thingy to get their databases data in a single Parquet files and then use Spark and all of those things to take it into Lakehouse. And you don't want to change those pipelines. You can directly use OLake to get your databases data into the Parquet file as well. Or we can directly push into Apache Iceberg. As I said, we already support most of the catalogs. We have Glue as one of the catalogs. Presto connects to the Glue as well, and then we have REST as another catalog. JDBC and Hive catalog is already available. So for this set of example, we'll be using REST catalog. You can name this anything, but like before, I'm just gonna use REST underscore temp to do this. Uh, these URLs or these configs, you can directly find it in the README file itself, right over here, and you can basically use that. If you're using anything else, if you're planning to use any other catalog or any other uh, destination, feel free to add those configs as well. And this is the S3 path. We'll be using the same database. We'll be creating the same schema name in the Iceberg, like weather, just for the consistency, but you can add anything you want. S3 endpoint. As I said, we are using Minio to basically simulate the S3 buckets. So that's why I'll be adding the Minio configurations over here. But if you want to use your own S3 buckets to do all of those things, you can do that as well. And you can add those configurations over here. It will basically test the destinations. Just like before, it will take a couple of seconds to check the destination out, check the connections, and then move to the next step, which is basically discovering the schema. So what Oleg just did now is basically discovered the database schema that you just said. It found one table called weather in it, and within that weather, it saw these many columns. It saw the column of, let's say, temperature, station, precipitation, year, week, and all of those things. And you can even add your own partitioning and all at the time of writing, like how you want to partition the data. Within the config, you can choose whether you want to have a full refresh or a CDC kind of a sync mode. Within the full refresh, whenever this job runs, it basically fully refresh the table from source to destination. Basically, takes the entire table always and pushes it directly into the destination. Within that CDC mode, it will just take the last logs. So it will just capture the last changes. We have enabled the backfill. So in backfill kind of a mode, you can have, when you have CDC plus backfill, it's basically will first full refresh the historical data and then start pushing up the changes. You can even choose whether you want to normalize the data or not. For the sake of this example, we are okay with, let's say, just two columns, one ID and another call with valid JSONs in it. And we can just have a job name called job underscore temp, orchestrate. We want it hourly, weekly, monthly, year. You can go as low as a couple of minutes, or maybe even lower. And yeah, we have a job created. So it basically runs a quick job. It takes a couple of seconds, so you need to refresh the screen, and you can check out the logs as well. So as you can see, we have some server already running, which has started pushing the data. Now, till the point this basically ingests, we can actually go and set up the Presto as well. To set up the Presto, you can go to the Presto folder within your own code. Just showing the README over here. For example, we have the README on how to set up the Presto as well. It's pretty easy. It's just one single command of running the Docker compose. And going back to the code, I can directly change my directory to the Presto, quickly run the Presto, and I have a Presto running. So when I go and check out the current running services, I find out there's one of those services as Presto running on this port, this container, and with 80 port, and then with an image of like Presto DB. So we have most of the things running already. We can do a Docker exec right into Presto CLI, or if you want to use Presto UI, you can do that as well. So we are into the Presto CLI right now. You can do like simple things like show catalogs, just to check if the iceberg catalogs is rightly set. And as you can see, there's an iceberg catalog which is already set up for you using those config files, which is already part of this playground. Uh, you can use command like use iceberg dot whether the databases that we just created, database that we just created, just to like simplify the query, or you can just skip this command and directly do select star from iceberg dot weather dot table name. And now we can even check out what tables were created using show tables. As you can see, there's already a weather table which is created for you. Ole created its own test table just to like register the catalog and all of those things automatically for you. You don't need to do that, register the tables and all of those things. It will do all of those things for you. And we can even do select star just to check out what data we wrote select star from weather. And Yeah, here we can see the data that we wrote. We disable the normalize. That's why we see all the raw files within this format. If we would have enabled the normalization, we will see the proper columns with keys as column names and value as the value. So we can even check out the history of this table, the snapshots, the manifest right through this Presto UI, Presto CLI. All we need to do is basically commands like select star from weather dollar history to check out the history of this table. As you can see, we have a couple of these snapshots that we created with different parameters, all of those things created at this. Or even you can even, if you want to check out the snapshots, like values and all of those things, you can do that as well. All you need to do is select star from weather dollar snapshots. Yeah. As you can see, we have done multiple operations append. So what Oleg does particularly, it basically chunks the data from your source and load it chunk wise. So that basically parallelizing the load for you to make it quick, to make it fast. And in a couple of minutes, you can see like what's the big performance difference that we see because of this operation. So you can see multiple append operations. You can check out multiple snapshots, parents ID. You can, as the next step, you can even try out like other features that Iceberg offers, like time travel or have schema evolution, or maybe if you want to add one more table into your database, Oleg will automatically discover that schema and sync it for you as well. Awesome. So going back to the presentation, we can actually check out a couple of things other than this as well. For example, if you want to check out like MinIO or see how actual data gets stored, you can check it out as well. We have all of those things set it up for you. For example, within this database, you will see, okay, there's a weather. Within the weather table, you have data and metadata, bunch of metadata files created over here. And within weather, you have bunch of Parquet files created over here as well. So all of this is already available for you. You can even check out Presto UI if you want to check out Presto UI. You can go use SQL, the SQL client to do all of these queries that we were running on CLI a couple of minutes back. So all of this is set up. You have a playground ready to use for you. And yeah, so right from the source, we basically just doing a quick recap. We set it up the MySQL source. We loaded some data in it. We initiated the CDC in it. Used the OLake to get this MySQL data into the Iceberg without any gymnastics of registering the catalog, registering the table, and we using the REST catalog by the tabular team, we basically have a Iceberg implementation on top of which we ran the queries using Presto, all within a couple of minutes. Awesome. So just reiterating on what all Olake handles for you particularly, it handles the schema evolution, discovery, both initial and incremental sync. It has its own CDC support. It creates the table for you. You don't need to register that table in Iceberg. No manual work required. It's fully orchestrated using temporal, and you can even use the same APIs to actually like orchestrate it from your own uh, orchestration tool as well. Maybe if you're using Airflow, Daxter, all of those things are pretty configurable as well. So, why particularly use Olake? The answer would be like the best performance out there and best configurability out there as well. As you can see, the numbers, we have almost like 46,000 rows per second kind of a benchmark. For full load, almost 37,000 rows per second. For CDC, we are almost 100 times faster than Airbyte. We are faster than 3 times faster than Debian in both full refresh and CDC in almost all the average scenarios. So if you want a quick, reliable way of getting your database data into your data lakes or data lake houses, this is pretty nowhere. So what's next? Of course, you can do more prototyping. You can check out Iceberg native features like time travel, or you can have your own staging tables as your sources, or use S3 buckets instead of MinIO. To test this out, you can have multiple things. It's all plug and play, as you saw in the Docker Compose. It's just a couple of services. It just makes it easy for data engineers like you data architects to basically get starts getting an introduction to the data lakehouse as an environment where you can have multiple pieces required to set up the data lakehouse or in a single place. It gives you the simplified view, self-contained data lakehouse uh, setup, and then you have quick way of prototyping. You can check out multiple catalogs. You can check out multiple ways of storing the data. You can check out multiple query engines. You can even check out multiple sources for this. And you can do all of this by trying it out yourself. So this is the one big pro of using this kind of a playground, and that's what we want to enable as well. This is it for my end. Get started. It's pretty easy. You can get started pretty soon. Uh, you can use this QR code to reach out to me if you have any questions, anything else, any feedback. Would love to hear your feedback, hear your thoughts on LinkedIn. This is LinkedIn. This is the GitHub of everything which you saw just now, where everything is hosted. So thank you. Have a great day. Bye bye.